Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Quick note before we begin, the Finding Genius Foundation, as part of the Finding Genius Podcast, has recently completed a book about understanding viruses. So the creation of this book was to interview 100 virologists, ask them a lot of deep, difficult questions, take the most difficult questions, and then re-interview the top 25 or so and ask them the hardest questions I could think of. And we compiled that all into a book. So you'll see question and 4 or 5 experts' answers. Question, 4 or 5 experts' answers. There's about 30 questions in the book. I think it's a great read for the layperson and for the researcher. It talks about a lot of speculation in the world of viruses, such as are they alive or not, and why is it important? Why do viruses go latent or hidden or ineffective or sit in a person or an animal or another creature for weeks, months, years, and then suddenly become virulent and affect that person? So there's a lot of really provocative questions in the book. It's now on Amazon. So if you go to Amazon and type in Finding Genius, you'll see the book on viruses. It's also on Kindle. The Audible version is in production and should be ready in approximately a month. But if you want to go and order it now, you can do so again by going to Amazon or Kindle, or go to findinggeniusfoundation.org and go to publications. There's an opportunity as well to get the transcripts of all the interviews and to hear the original interviews themselves. If we put them all together, the book would be about 1,000 pages, but we condensed them down to make it juicy and concise and tight and very interesting. So I hope you'll check out the book. We're now working on one about cancer, but this is going to be our goal is 3 times a year to come out with these masterclass books that I think will inspire new scientific research, and I hope you'll check it out. Thank you.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have a returning guest, long-term mentor of mine and a friend. His name is Perry Marshall. He started out as essentially a marketing guy, dealing with Google, pay-per-click, and all kinds of online marketing, including Facebook, etc. He got a tremendous amount of expertise there and built a huge following, of which I became a part of. And so I learned a lot from him. And then he hasn't really switched, but he's kind of added on a new passion that I think is where his life is going now. And that's looking at evolution. And I guess he'll better encapsulate it than me, but where does life come from? Why does it appear to be designed by some intelligent source, and why is DNA to appear to be a code and not just a jumble of nucleotides that arose randomly? So he's gone into evolutionary biology, and now, based also on his life experiences, I would guess he's created what's called the Cancer and Evolution Symposium, and they're having monthly meetings where they have top level speakers come in and talk about new perspectives on cancer. And I reckon there's also a large symposium coming up in about 6 months that he'll talk about. And he's just involved in a whole host of activities. Probably one of his biggest is a $10 million prize that he has advanced for anyone that could essentially find how and why life is created essentially from DNA code, or to make life yourself from non-life. Obviously an incredibly tough challenge, but he has that $10 million prize, which to my knowledge is the biggest prize around for such a thing. So he's morphing and changing and evolving into all these, really beneficial efforts. So I want to talk to him about what's going on recently. So Perry, welcome back. Thank you.
Thanks for having me on your show. And I love the questions that you ask, and I think we're going to have a great conversation. So,
well, good. Well, tell me, so what prompted you to start looking at cancer? You were working on evolutionary biology, but how did you get into that realm?
So about 1.5 years ago, I was in Australia. I had just finished a seminar and I was taking a day off, and I was in a park and my phone buzzed, and my friend Bill texted me and a group of other friends and said, "Hey guys, my wife has pancreatic cancer." Well, I've had a front row seat to that because my very, very, very close friend, Tom Hubyar, had that and died of it in 2011. And so I was like, ooh, here we go. It's one of the worst kinds you can get.
Yeah.
And well, she was gone 5 months later. But the interesting thing is that the very same day that I got that text from Bill, I got an email from James Shapiro at the University of Chicago, who I've been friends with him for a very long time. And he's been my mentor in the evolution space. And he was mentored by Barbara McClintock, the famous Nobel Prize winner, who's really, her discoveries really changed the whole nature of evolutionary theory. And he said, I've got these two other guys, and we're putting together a cancer and evolution symposium in Cambridge, Massachusetts. Would you like to help? And I said, absolutely, I would like to help. And so off I started on this new venture. Well, so what does cancer have to do with evolution? Well, if you look up cancer in a medical dictionary, you'll get a lot of different answers, but they tend to be clustered around the idea of it's a genetic disease that causes from random damage to the DNA, and it triggers like never-ending cell proliferation. And that's kind of true, but I don't really think it gets at the essence of what cancer really is. I think if you want the most elegant answer of what cancer is, it is when the bodies, the cells of your own body do mutiny or lose their identity and suddenly start speciating or evolving, in other words, out of control in your own body. And that definition gets much closer to the true nature of the disease. Because when you start fighting cancer, like when you frame it as an enemy and you start fighting it, you successfully kill most cancer cells, but you can almost never kill all of them because some small percentage will evolve faster than any medical interventions that you can put together. And so this is why stage 4 cancer is still pretty much a death sentence for most people. There are a few exceptions, but not too many. We haven't really made that much progress. And the framing it as a war, it sort of like puts us in Vietnam, you could say. It puts us in an unwinnable war. And so I was very enthusiastic about helping these guys, and it was going to be probably at Harvard or MIT, but ended up moving to Zoom because of the pandemic. And it was a great success. It was last October. You can go to cancerrevolution.org and you can see all the presentations. And it became a very, very interdisciplinary of people from a whole bunch of fields, ranging from physics and astrobiology to numerous disciplines within cancer and evolutionary biology and other fields. I presented on information theory at that conference. And so, so the reason we're not fighting cancer successfully, the reason why the war on cancer has been a failure, first of all, it has to do with using a wrong definition of cancer in the first place, where it really needs to be defined in terms of evolution. And then secondly, for those that do define it in terms of evolution, most are using the wrong definition of evolution, because most people are using essentially a neo-Darwinian view of evolution rather than really cells have cognition. James Shapiro published a paper last year called All Living Cells Are Cognitive, which in plain English basically says all living cells. And, when Jim says all, he means all. He doesn't mean an awful lot of them. All living cells are smart.
Just to be clear for a moment, does this include amoebas, fungi, bacteria, human cells?
Yes.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
Yes, so he's talking about blood cells, human cells, bacteria, even prokaryotes, eukaryotes, fungi, slime molds. That life is capable of self-modifying. It does so in response and context to whatever is going on in the environment, and that these same capabilities are invested in the physiology of the cells of our own body, and they can get stressed out, and they start manifesting different behavior, and a tipping point comes where they basically forget who they are, and they no longer think they're Rich Jacobs. I mean, you've been through cancer, so you know about this.
I couldn't ask my cells, unfortunately, why they did this to me.
Right, but that's almost what you want to do, because I don't know how to categorize the intelligence. I mean, I don't know that I would call it consciousness. Maybe that's what it is. Maybe other words like sentient, or I don't know. But what I would say is that whether you're watching football players chase each other around the football field, or whether you're watching your dog chase a rabbit, or whether you're on a YouTube video watching white blood cells chase down germs, it all kind of looks the same. It looks awfully similar. It's like it's fractal. It's the same intentional behavior happening on radically different scales. And so I think that's the only honest way to approach the problem. And the problem with the old view of evolution is the old view of evolution insists that essentially the cells are dumb and the only directive force is natural selection. Well, you'll never, ever cure cancer if that's what you think evolution is. You'll consistently misunderestimate what you're up against. It'd be like saying, hey, that pipe bomb that blew up in that store at the mall the other day? Yeah, that was just totally random. There was no actual reason why that happened or why it happened there. There was no motive. Just go on with your life.
Yeah, this is something I wanted to bring up with you. Anytime you mention anything anthropomorphic, people go, "Oh, no, you shouldn't say that. It's like a bad thing." But if you deliberately consider things from that standpoint, and you assume that they're capable of any, if cancer is capable of anything, any organism that has cognition of the same type of abilities, then at least you have an expanded palette of things to look at. And you're not narrowly thinking, okay, this is just machinery and it's not capable of this and that. And I'm not even going to entertain that. Therefore, my view is limited.
Well, Rich, the anthropomorphic language has been frowned upon in biology for 100 years. And you know why?
Why?
I think it's because it's the only way to understand it. And I think there's a lot of people that just don't want to understand it. Or if it raises questions that sort of blow my mind, I just don't want to think about that.
Yeah, I think it leads in the direction of, of spirituality or religion. And I think that's another reason why people are so uncomfortable with it, because they don't want to go anywhere near that. That's another thing that's been told to, that people have been told not to talk about or let influence science, unfortunately.
Well, right. Like if you find out that you cannot explain everything that happens in terms of simple laws of physics and chemistry.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
then all of a sudden you have this giant elephant in the room that nobody knows how to deal with. Now, I've been dealing with this head on for 17 years, and I am a Christian, but I also understand that just because you don't understand something doesn't mean you say, oh, well, see, God did it. Like there's a very lazy way to approach this problem, which a lot of people have done. And so in order to make an end run around that, people on the opposite extreme have pretty much issued a prohibition against using purposeful language, against using anthropomorphisms, against suggesting that evolution or life itself is inherently intelligent. And so really it's like cutting off your nose to spite your face. And this is what's been going on pretty much ever since Darwin. Darwin didn't so much do this, but his successors did. In fact, Darwin believed that cells and organisms, whatever it is that they learn in their lifetimes, that they have the ability to pass that on to their offspring. And he was later ridiculed for believing that. And only in the last 20 years has it become absolutely abundantly clear that he was right all along. And his predecessor, Jean-Baptiste Lamarck, was really the champion of that idea. Lamarck was just excoriated in biology books for believing such a silly thing. But now that actually turns out to be true. Yep. So think how long this has been going on, right? I mean, this is 1859 to now, it's 150, 160 years, right?
Well, I can tell you, though, in my interviews, the penetration of neo-Darwinist thought is probably still 90, right, maybe 95%, but at least 90%. So it may be getting there, but it's small still, this more encompassing way of thinking.
Well, the trouble with the more encompassing way of thinking is it's more nuanced and it's more difficult to explain. Like the old version of evolution is so easy to explain that if people think that they now understand it once they got the explanation, it's kind of like eating a Ziploc bag and thinking you got a ham sandwich. So like the theory of evolution as normally presented in textbooks, it's variation and natural selection, and, all you do is add time and you pretty much get anything. It really fails to answer any of the most fundamental questions at all. All it really does is sort of sweep them under the rug. And so we have all of these questions like, well, how do those cancer cells know how to make the next adaptation? What are they doing? How are they making these guesses? How are they restructuring their genomes? And they do massive restructuring of their entire architecture at the highest level. Henry Hing is one of the members of our group, and he's at Wayne State University in Detroit. And he has a book called Genome Chaos, where he explains that cancer cells completely restructure their entire chromosomes. And so this is like, if you want to think of the genome as a set of encyclopedias, it's like they are rearranging the articles in an entire set of encyclopedias. Like, okay, let's take the one from S and move it over to J. Let's take the one in I and move her over to K. And
actually, it's even crazier than that. At least it appears to me there's a subset of encyclopedias that each cell type has access to. But when it comes to cancer, all of a sudden they're able to access this hidden library that was, heretofore unobserved, at least in those cells. And there's this invisible library, it seems, that all cells can access under the right conditions.
It's incredible. It is absolutely spectacular if you can sort of set aside the tragedy of it. The capabilities of these cells are remarkable. And, all you have to do is point to the fact that there is not a single chemotherapy or medicine or radiation or gene treatment that consistently, successfully stops cancer other than a very few diseases that are incredibly simple compared to the worst ones. And so it is beyond any human comprehension that we currently have as to how this really works. We only understand it at a surface level. And so the Cancer and Evolution group has endeavored to educate the field and to bring a whole new viewpoint into oncology. And so it's really been incredible to work with these people for the last year and a half and see what's developed. So,
and I wanted to ask you about that. So you couldn't have been unaffected by running these meetings yourself. I know you presented at them, but you have the privilege of, first of all, having an open mind. Second of all, having access to these disparate, experts. So you've done several of these, Cancer and Evolution monthly meetings. How has it changed your view on it? Like, what new things have you learned that surprised you, that informed you better about it?
Well, so I knew back when I wrote Evolution 2.0, which came out in 2015, I knew that cancer is evolution running out of control. But I'd never gone down the rabbit hole to really try to understand what's going on. So there were a number of things, technically speaking, that were remarkable, which I kind of alluded to, like the genome chaos and the incredible speed and responsiveness. Like, I didn't know when I wrote Evolution 2.0 that when you start hammering tumors with chemo, you can go from one species of cancer cell to 1,000 species of cancer cell in a month. I didn't know that. I would say the more unsettling things were the degree to which the medical industry is resistant to change, the degree to which it has it has gotten so hyper specialized in all of these tiny nuances of cancer behavior that it's like there's 10,000 cubicles and there's a little tiny niche of research going on in every single cubicle, and there's not a whole lot of people that have a comprehensive view of what everybody is working on. They
won't even entertain the other views. I mean, I know it's a mixture between they have to get grants, they have to focus on what they're doing, but they also are afraid or just don't or won't or can't. I don't know. They won't entertain stuff. I hear, oh, I'm not an expert in that. And then they won't answer. Oh, that's not the focus of my research. Oh, I don't think that applies. And then mind is shut, done.
Well, yeah. And that's because, so any marketer can kind of understand this. In marketing, if you want to create a new car company, you can't just make more cars that are just like everybody else's. Like, you've got to do something new, right? Like Tesla started doing stuff that was pretty new, right? So, it's not like a lot of new car companies have started in the last 20 years, right? I mean, it's a very tough business. Well, in science, you have to take some discipline within science and subdivide it and start working on something that nobody else is working on. And if you can do that and make a case for your work, you'll get funding and you'll publish papers. And then, you'll be an expert on something that only, 15 other people in the world are experts on. And so that's perfectly understandable. But, this is also the way you keep other people from stepping on your toes. And so as long as everybody stays in their lane, then you don't upset the apple cart too much. But if somebody shows up and wants to figure out how everything fits together, that's like a whole new thing. And there are a lot of problems with that. Like, first of all, they should. Like, absolutely they should. Well, like, we need as many people as possible looking at all the different subspecialties and trying to form coherent overall models, from all the granular information. But as soon as you start doing that, you're going to be kicking over apple carts and killing sacred cows. and people are going to get mad at you, and they're going to gang up on you, and they're going to do their best to get you relegated to this guy's a quack or a kook or a maverick, or, you know, whatever you want to call it. And so there just aren't very many people that are willing to poke their head up above all the cubicles and try to put it together in a cohesive narrative. And the funding agencies don't want to pay for stuff like this because that puts their reputations at risk. And really, the whole field is very risk averse. And so mostly what they do is they just incrementally add to the existing bits of knowledge within the existing paradigms. And almost nobody gets paid to upset the paradigms. And so it becomes very entrenched.
How are your contributors reacting to this? I wanted to ask what they've learned and what they've told you. But before that, are they, you know, you don't work for a university, you're not in a lab, and you're not under the thumb of who knows how many people's interests, but some of your collaborators, I'm sure, are. So how are they handling this, and how are they navigating this?
Well, so what I've seen is that most successful renegade scientists figure out some way to fund their research, either by alternative sources, in some cases with their own money, or they figure out some way to do it on a shoestring or whatever. But, you know, really, you can't have intellectual freedom without some level of financial independence as well. And like, I consistently find scientists who, you know, they pay a price for having a viewpoint that's different from everybody else. So I'll give you an example. One of my friends in this business is Jin-Sung Liu at MD Anderson. And he's a pathologist who studies cancer. And so he's cut open lots of cadavers and then traced, like, okay, you know, how did these tumors spread and how does all this work? And well, there is something in cancer called a giant cell. And a giant cell is basically when your body gets stressed out. It could be chemicals, it could be toxins, it could be your work or whatever, but there's stress going on. And at some point, some of your cells start dividing abnormally. And the first thing will happen is, instead of dividing when a new set of DNA is copied, they'll keep growing and growing and replicating more copies of DNA inside one cell. And so they call that a giant cell. And so you'll have a few of these floating around in your bloodstream for, you know, maybe a couple years. And eventually it will turn into cancer. They'll start spilling out cancerous cells. But there's kind of this middle space where it's almost like at stage -1. Well, Jin-Sung was doing interdisciplinary research, and he figured out, hey, wait a minute. The growth cycle of these giant cells is almost identical to an embryo, like a baby, except it's like the dark evil twin. And he connected all these dots. He's like, okay, this matches up to this matches up to this. Hang on a second. I think we can actually figure out, it's almost like we can figure out what a pre-cancer cell is thinking and doing, because it's kind of doing the dark cousin of healthy embryo development. And so he started trying to publish this, and like, people looked at him like he had an asparagus growing out of his forehead. And it was ridiculously difficult to get anybody to fund this or accept it for about 10 years. And then finally, some people started listening to him.
Wow.
And so what I've seen over and over and over again is that if you're going to say, well, hey, everybody, you know, the standard accepted view is X, but that's wrong. Let me show you why Y is really better. There is typically not a lot of receptiveness. Usually you're going to have to battle through layers of defensiveness because everybody's careers are threatened with a paradigm shift. And this is not new. And what I consistently observe is that scientists who stick to their convictions, they end up paying a professional price for sticking to their convictions. And it may take quite a long time for the field to accept them, if it ever does. And
well, the good thing is, with COVID this past year and a half, like science has become, I'm joking, so much more tolerant of other views. And, there's a lot less censorship and cancellation. So it's headed in the right direction.
Well, look, cancel culture has been going on a long time, in science, before it ever started happening in mainstream media. When Dennis Noble organized the Royal Society Evolution meeting in 2016, which was absolutely revolutionary, a whole bunch of people tried to literally get that meeting canceled. They weren't able to do it, but they tried very hard, and they would have succeeded had Dennis been a typical scientist or a typical meeting organizer. It was only because he has so much street cred in the field that he was able to get it to go.
Wow.
So this is one set of problems, and another set of problems is it's become apparent that the financial incentives in the cancer business favor the old existing solutions. I mean, there's a lot of forms of cancer. They're pretty much getting treated the same way now as they were 20 or 30 or 40 years ago.
Yeah, one thing I saw, Perry, is a lot, I don't know about all, but most treatments have to be done alongside the standard of care, meaning chemo, radiation, surgery, all that. You can't even evaluate them independently. So chemo, radiation, all that, obviously it makes the battleground a million times harder for any other therapy. So that's also another crippling force that I've seen.
Well, that's true. And I have heard accounts of pharma companies who sell chemo therapies shutting down early detection, like buying early detection companies and shutting them down because chemo is profitable. And so I don't think of this in terms of conspiracies. I think of it more like monopolies and maintaining monopolies and monopolistic behaviors. And the problem is that the monopolies exist within the government-funded paradigms of research. Okay, so any scientific research paradigm is subject to monopolistic forces as an ideology, just like any company like Microsoft or U.S. Steel or Carnegie or Rockefeller or any of those monopolies. They all kind of work the same way. And I'm a business person, so I completely understand this. You don't even need evil people. You just need people who are meeting their objectives that they have been given by the shareholders and management for this quarter. And that kind of stuff will just happen.
So what feedback are you getting from the people that are participating in this group that are presenting? Are they watching other presentations? And are they saying, Perry, I learned something from so-and-so's presentation. I'm going to use it in my lab and change the course of what I'm doing?
Oh, yes. It's a very vibrant group with lots of cross discussion and really great presentations. In fact, you can go to cancerrevolution.org and you can sign up. And by the way, today, I need to be clear. I am not speaking as an official representative of cancerrevolution.org. I am speaking as a person who's a participate in it. And, other people may have different views in the medical industry or whatever. But I am speaking as well. I started a nonprofit organization called Science Research 2.0, and we are funding various initiatives that we think are interesting. And I'm just glad all these people are talking to each other, because it is extremely rare for groups of scientists this diverse to engage in an ongoing conversation about a topic like this in such depth. Usually science is a lot more niched than this, and you will not typically have astrophysicists and evolutionary biologists and clinical oncologists all on the same Zoom meeting or all attending the same webinar and vigorously talking to each other.
Yeah, what do they say about that when they're on? I mean, like, what are you noticing about the interactions? Because you're getting people with such radically different backgrounds. This is super cool. It's exciting. Like, what do you notice when they're talking?
Well, so for example, the most recent meeting we had, one of the guys was an ecologist. He studies biology at the ecosystem level, and this is the sort of person who would ask questions like, well, what does happen when you introduce rabbits to Australia and they've never been there before? And not only, what are all the crops that they eat, but like, how does that change all of the species and the rest of the environment and, and all of that? Well, and so we got into this whole discussion about why are cancers almost never contagious the way that other diseases are, although they can be in rare occasions. And he gave this whole ecology explanation of why it would be extremely difficult and extremely unlikely for a set of cells that are well adapted to kidneys and can spread to the liver, why it would be so hard for them to jump out of your body and go to somebody else's body, okay? Well, most of us aren't used to thinking about that, right? And then there was the same session, there was a physicist who did mathematical, he was modeling robotics based on, and he built this whole entire model with physical robots. I don't really have time to try to explain it, and I'm not sure I do a good job, but it was basically modeling evolutionary behavior with swarms of robotic programs. And it was, and then he was tweaking variables and measuring, which things survive and proliferate, which ones don't. And so we have these conversations, and they make extremely interesting analogies. And of course, everybody in the room is going to hear it through different filters and apply it through different ways. But everybody's being challenged to think about things that they're not normally accustomed to. And at the end of the session, I chimed in. I said, well, what's funny is this is the exact same pattern I see in Google ads and Facebook ads, because those are ecosystems too. And they're like, oh, well, yeah, I didn't expect that to come up, right? So that's a lot of fun. And I just think we need a lot more of this in medicine, a lot more of this in science. This is how breakthroughs happen. When people from different fields start talking to each other and changing their idea of what should be the norm.
You've been doing these monthly meetups, and I guess they're over Zoom. And the symposium, when is it? Where is it? And what's the goal of that? Is it a kind of a master session? Is it in person?
So the sessions are monthly, and if you go to go to cancerevolution.org, you'll see them there, and you can sign up, and anybody can attend. And then we have a full 3-day meeting, October 18, 19, and 2021. And we haven't nailed down the details of that yet. It very well may be in person, but it kind of depends on how the pandemic tapers off. But anyway, we do have dates for sure, and for sure we'll be on Zoom. Whether or not it's an in-person meeting, it'll probably be a hybrid meeting. And so we're already lining people up. One of the sessions I'm looking forward to in July, which is one of the virtual ones, is Evolution 2.0 is hosting it. We have different institutions and universities that host these every month. And so we've had Columbia and Arizona State University and USC and different ones. And Evolution 2.0 is hosting the July. And I'm featuring Kim Bussey, who is...
let's talk to her. She's great.
She is great. And I'm hosting Azra Raza from Columbia, who wrote the book, The First Cell. And Azra is going to be explaining her program for detecting cancer at stage -1 based on giant cells, which I referred to earlier when I talked about Jin-Song Liu. So this is all very exciting, and it is helping me sharpen my sensibilities because, I'm running a nonprofit organization where we're funding cancer research that the other sources won't fund because it's too far outside a paradigm, or it's too anthropomorphic, or however you want to describe it. And so if you go to evo2.org/cancer, you can find out more about what we're doing there. And I think this is very, very important work.
Okay, very good. So EVO, the number 2.org is the website to go to?
/cancer. Yeah.
Oh, /cancer, yes. Okay.
EVO2/cancer.
Yeah, last question or so, Perry. So what do you see as the outcome of the symposium and these monthly meetings, and on what time scale? Like, what do you think you could accomplish in the next 2 years versus like the next 10 if it keeps going?
Well, one of my friends says most people overestimate what they can achieve in 1 year and underestimate what they can achieve in 5. I think some of our researchers really have their finger on major, important, fundamental questions. And I think there's some serious opportunities for real progress, especially because COVID-19 has reset the expectations of the science and medical community about how fast government should be able to approve drugs and solve problems and try different treatments. And Science Research 2.0 is bringing a interdisciplinary approach to and an entrepreneurial approach. I think there's not nearly enough entrepreneurship in science. Science is mostly done by straight A students trying to get straight A's. And Rich, the only way to get straight A's is to not take a lot of risks.
That's true. You got to study what you're given.
You and I are serial entrepreneurs. I don't know how many businesses you've started, but between the two of us, it's a lot. And 70-80% of what we do fails, even with the very best advice and everything else, or at least it doesn't really get off the ground. And we're used to it. It's like, okay, pick yourself up, dust yourself off, and go again. But the thing about entrepreneurial thinking is, you only need to hit the ball out of the park one time out of 100. And so that's what we do.
Well, excellent. So evo2.org/cancer.
Mm-hmm.
And if you would just speak very briefly about the Evolution 2.0 prize, because I always want to point people towards that, because I think even if they don't participate in a submission of the prize, it's just an amazing thing to look at. So where can they find out more about that?
So if you go to naturalcode.org, you'll get taken all the sites and videos and everything where we have the largest fundamental science prize in the world. It's $10 million. It asks the question, where did the genetic code come from? Which is really as deep as that is, because that's a key to the origin of life. It's also the secret to artificial intelligence. And it's really key to a lot of fundamental problems of humanity. And it has a lot of different angles. So if you go to naturalcode.org, you can watch the announcement that we made at the Royal Society 2 years ago, alongside prize judge Dennis Noble, and really start to peel the onion to see what that's about. And I believe if we can solve this problem, we will understand what makes cells tick, what makes biology, what makes cancer cells tick, and it'll be a huge leap forward for humanity.
Excellent. And I also encourage listeners to go to Amazon and get Evolution 2.0, Perry's book. I've been through it, I don't know, 6-7 times with myself and my kids. And, it took that many times to really get my mind into this track, and it's gone from there. So it's another resource for people I wanted to point out.
Well, Rich, thank you for doing that. And thank you for catching the bug and going down the rabbit trail. And now, you're having a lot of the same conversations I am with people.
Yeah, Perry, thanks for coming. I really appreciate it.
Appreciate it. Have a great day, Rich.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.